pleased to welcome Remy Vandaele. I'm not going to say anything because we're behind time now, so over to you, Remy.
So, hello everybody, so I'm Remy Vandaele, I work here at the university. And today I'm going to present you a work that is also about using Prithvi actually, but using geospatial foundation models to detect wildfires in the UK. So to give you a little bit of background, this project starts from another one, which was called GreenSight. So the aim of that project was to support the development of Quest, which is the Met-Office digital twin demonstrator that tries to assist in multi-objective land use decisions with a focus on UK green belts. And so with GreenSight, we try to inform this digital twin into two key areas, so carbon dynamics that Victor has been working on. And on my end, it was about wildfire occurrence. And so during that project, what I have done was basically try to collect UK wildfire datasets and try to see if there were any particular seasonal or yearly patterns looking at these datasets. But also, more interestingly, I tried to map wildfire polygons with typical land cover maps. So, for example, from UKCH or the one from Living England. And so the idea was to see which kind of land cover were the most affected by wildfires, which could be extremely useful to assist this digital twin. But the problem is that the datasets that I had been using all had their own limitations. So I used the FIS dataset that processes MODIS images, but there only large fires are recorded. We were able to get our hands on the Dorset fire intervention dataset, but that also provides smaller polygons. But there, as you can imagine, it's only limited to the Dorset area. And also the Home Office statistics that provides fire intervention statistics for all of the UK. But this time, we don't have any access to polygon data or accurate wildfire location to perform the land cover analysis. So, having been working on Prithvi for another project, my idea was to try to leverage the use of these geospatial foundation models to try to generate a more comprehensive datasets of records of wildfires in the UK. So basically use satellite images to segment wildfire burn scars in the UK. And so the first thing that I wanted to do was to try to evaluate the performance of the Prithvi geospatial foundation model for this task, so fine-tune it and validate the model on the polygons that I had. And then, but this is not what I'm going to talk about today, but what I want to do with that is to try to develop a full pipeline to create a new database of wildfire records, at least in the recent times. So, well, I'm really well educated. I use the Prithvi 2.0 geospatial foundation models, which has a vision transformer architecture, and that was pre-trained on the mask auto-encoder task using a lot of data. So it was fine-tuned and validated on a wide range of applications, including burn scar detection, but on a US dataset. And it uses HLS Sentinel and Landsat. So what I had to do first was to try to create a dataset of UK wildfire polygons. So what I did was try to match HLS patches with the polygons that I had at my disposal. So I only selected HLS images that were available within 10 days of a given wildfires. And I removed all the patches where I didn't have a sufficient amount of data, so at least 50%. And during training, so I could then do some additional random cropping to do some data augmentation from these larger patches and still keep at least 1 pixel of wildfire. So the wildfire polygons comes from the two datasets that I have presented you. So the FIS dataset that only captures the largest wildfire, where I have about 940 patches, and the Dorset Fire Intervention dataset that also captures much smaller wildfires, where I only have this time 129 patches, but compared to the EFIS for that area, I only had access to 3 wildfires and 129 with the Dorset Fire Intervention dataset. As you can see here, most of the EFIS dataset locations are actually in Scotland North. So I did quite a classic experimental protocol. So I trained everything on the EFIS dataset. I used 5-fold cross validation, and I compared PRIDV with other methods. So I used PRIDV with the pre-training and also with randomly initialized weights that I call scratch, so not fine-tuned, but trained from scratch. Using the 6 HLS bands, I compared this with a pixel-wise random classifier to detect the burn scars. There, as I had access to the full HLS images, I used the 12 HLS bands. And I also compared this with the normalized burn ratio, which is not really a machine learning approach, but that is classically used in remote sensing to detect wildfires. And so I used the mean intersection over union error criterion to try to balance the performance evaluation, as the wildfires are quite small and we want a good representation and not a biased one, as the fires were quite small. So the results here, you can see that the geospatial foundation models was clearly outperforming the other methods. The approach from scratch was outperformed, but also the random forest and the normalized burn ratio. And here is a typical example of what I could observe, is that the approach from scratch was actually missing the smaller fires, and the random forests were generating some false positives, while the normalized burn ratio could work on some images, but most times it was kind of missing some wildfires and generating also false positives. So I used also this model, the model that was trained on the EFIS dataset, directly on the Dorset Fire Intervention dataset, that, as I said, contains much smaller wildfires than the Dorset dataset. And you can see that the performance have really decreased. However, you can still see that the geospatial foundation model works much better. And one big explanation of why this model doesn't work as well is because most of the fires are extremely small. This is Dorset Fire Intervention dataset, so smaller than 2 hectares, which is less than 22 pixels in the image, which is quite small, especially given that I was training my model on EFIS. And you can see that when we only look at the biggest fire on the Dorset Fire Intervention dataset, the performance really increased, and PRIDV is really outperforming also the EFIS detection that only detected 3 of these larger wildfires. So that's it for the presentation, basically. So I tried to evaluate PRIDV to detect wildfires in the UK. I built 2 databases using EFIS and this Dorset Fire Intervention dataset. I showed that the geospatial foundation model outperformed the other approaches. And this Dorset Fire Intervention dataset is much harder to detect, as there are much smaller wildfires there. In the future, I think that one obvious thing to do is to use this Dorset Fire Intervention dataset to train the models. I think it will quite easily improve the performance, but also, especially for the training, what I think is consider non-UK datasets to train on, so I have more data, and this could I think, really improve the performance of my models. I also can consider smaller image crops as inputs. I think this could potentially improve the detection of smaller wildfires. Validate the model using additional datasets, because you can have access, as I said, to actually all the wildfire locations, but not their polygons. So we could try to use that for the validation. And finally, as I said, the real goal is to try to generate a new database of wildfires in the UK, especially in the Midlands. So then I will need to use that model. So that's it for me. Thank you for your attention.
Okay, thank you, Remy. So you spoke quickly, so we've recovered some time. So there's enough time for maybe one or two questions. Yes.
Can I just ask for clarification? On your slide where you said you discarded images with more than 50% no data, do you also mean images with more than 50% cloud cover, or that you discarded pixels with cloud cover?
No, I discarded the whole image.
The whole image. And how are you, is there a way to distinguish between cloud cover and like smoke that comes from the fires? I don't know. I don't do that.
I think so, yeah. With the HLS data, you have access to a mask.
Right.
That gives you this kind of information. And I also discarded this kind of...
Thank you.
Okay, where's Joseph? Joseph Paolo is our next speaker.
We haven't been able to get in touch with him over the last several days.
I haven't seen him.
So I think we're moving on to the next speaker.
Okay, well that's exciting. But in that case,
It's us closer back on time.
Has another question for Remy. We do have time because our next speaker is not here.
The thing you're doing is something that I've worked with a lot as well, and finding small fires is really difficult. A lot of my colleagues use active fire data, and I didn't see it come from your slide, so I was wondering if you'd considered using that, and if you hadn't, why?
I'd be interested to talk to you, actually.
Yeah, okay.
One last question and then we'll move on.
So one project I've been working on, we started looking at but didn't finish looking at the use of burn scar to try and then compare the shape of the burn scar to try and identify whether it's a wildfire or potentially somebody setting it to convert land for agriculture. In your work, have you actually looked at the shape of the burn scar to see if you can determine any inference as to why that fire is where it was?
So the dataset that we use are wildfire datasets, so I'm not sure that they would be recording.
Probably not any deliberate ones.
Yeah, I don't think that I could do that with the dataset that I have. Potentially, yeah.
Okay, let's thank Remy once more.